Two notes, polar and rectangular forms of equations. Yesterday we did coordinates, now we are doing equations. So same thing as yesterday, x is still r cosine theta, like literally with the letter r. We have to have the letter r there. And then same with y, it has to have the letter r, but it's going to be sine theta. Remember to find r, it is the square root of x squared plus y squared. But when we're writing equations, guys, we can't write x and y under a root. So please write this down because this is the format that we're going to use a lot for equations. So if r has a square root, r squared does not have a square root. That's very important for us. And then tangent is the same as it was yesterday. It's y over x. All right, so the top half of this, we're going to take these polar forms and we're going to write it in rectangular form. Rectangular has letters x and y. And just remember, x and y are on the same side of the equal signs. I'm not writing of equal sign. Just remember, x and y are on the same side. All right. So let's analyze what's going on here. Each one of these is going to be tackled differently. Just remember your end game. You have to have the letter x and you have to have the letter y. And the only way you're going to have a plain x without an exponent is it has to have the letter r next to it. The only way you're going to have a plain y without an exponent, it has to have the letter r next to it. Okay, so the reason why I bring that up is I see sine theta. Sine theta is almost the letter y, but it doesn't have an r. It has to have an r over here. And that's an equation. So I can multiply it by an r, but remember what you do to one side, you do to the other. So now what we're going to have is r times r, that's going to be r squared. And I'm just going to rewrite this to look like this. So I'm going to write 4, but then I'm going to put the r in front because that's how we're used to seeing it. So now that I have the r in front, we've got a couple of straight substitutions. R sine theta, boom, is the letter y. But over here, r squared, I'm going to drop this in for this part. So x squared plus y squared, that's r squared. And then 4y, because r sine theta is the letter y. But remember, x and y has to be on the same side. I'm going to move that y over and set it equal to 0. That's it. That's the answer. Okay? So, let's talk about number 2. Number 2, we have a plain r, but y'all, we can't write rectangular form with a root. So what I'm going to do here is I'm going to square both sides. And I know this is kind of new, so let me just reiterate why I squared this versus why I multiplied both sides by r. The reason why I squared this is because I don't have sine or cosine. The reason why I multiplied both sides by r is because I had sine, but I needed an r next to it. So now that we've squared both sides, r squared is x squared plus y squared. That's it. That's the answer for that. All right, let's take a look at number 3. Guys, again, if it does not have sine or cosine, then we can't do anything with it. So this cosecant business is nothing for us. So we're going to rewrite cosecant as the reciprocal of sine. So r equals 4 over sine theta. We don't want cosecant ever, or secant, when we're working. Also, y'all, there's no fractions up here, so I got to get rid of this fraction. So I have to multiply both sides by sine theta. All right, those cancel out over there on the right, which is perfect. And then look, this is going to be the letter the letter y. That matches y exactly. So this is just a horizontal line. at y equals 4. Okay, now let's take a look at this next part. So for polar form, remember polar form has the letter r and it has theta. So that needs to be in the equation. Just r by itself is ideal, but sometimes you have theta with it, sometimes it's just theta. So we totally need to focus on the end game here. R is ideal, but sometimes it's just theta, sometimes it's both of them. You're just going to have to analyze each problem, and we'll talk about it. Number 4. Y'all, number 4 is x squared plus y squared. That is r squared. So number 4 starts out easy for us. It's straight substitution. But look, everything's to the first power here. So we're going to root both sides, and we always want the positive root. So r equals 3. That's all we had to do for problem 4. Let's look at problem 5. Problem 5 has a y value to the first power. So if it's a y value to the first power, it's this business. So down here, I'm replacing y with r sine theta. And then remember your end game. We really do want r by itself. Can I make r by itself? I can. I can divide both sides by sine. So let's divide both sides by sine. I'm sorry, I should say sine theta. So r equals 5 over sine theta. However, we did solve. We're done solving. If you could clean up a fraction, then clean up the fraction. So we're going to use the reciprocal property on this. So our final clean answer is r equals 5 cosecant theta. So it's okay to have cosecant and secant, but just not in our work. Not in our work. Not during our work process. But a final answer is totally good. Number 6. Y'all, number 6 is just like number 5. Try to do that one on your own. You're just going to have the word cosine.